Oh, you want that? Okay, sure. Helps you wander around. Yeah, there you go.
Hello everyone. Today we're going to talk about LOWC2, living off the web command and control. This is a story. This is my story. So we'll start about who I am very quickly. My name is Mathieu Saulnier. I'm a senior manager at Sophos. I'm also the co-organizer of SkiCon, a cybersecurity conference that favors healthy life habits. It is in the Boston area this year. If you're interested, the CFP are open. I'm also the Montreal on-site lead for Defcon, a 100% hands-on cybersecurity conference focusing on detection engineering and threat hunting. And I've been in IT security for over 20 years, which means that after 20 years in IT security, I often feel a little bit like this. So I told you this is my story, and it has a very sad start. Every story needs a sad part. So it started when I was let go from what was at the time my favorite job, or my perfect job, and I was laid off with roughly 100 other people that were all in security. So, sad start, got laid off, 100 other people, and although I know that the last thing the community needs and the world needs is another free C2, that is actually the one idea that kept me going and really motivated me. So, but to be fair, this actually started even before that. It started when I watched that talk, when I watched that talk from Matt Graeber and Chris Campbell called Living Off the Land. And this is the inception of everything living off the whatever. And I have a little trivia for you. On this very slide, there is one word that is triggering their C2 framework. Can anyone in the audience tell me what the word is? Okay, so I thought maybe it was a bit more like of a classic. The word is catawampus. So you can thank Matt Graeber for that. So I was trying to think about the most inoffensive website I could think of that would also allow you to read, write files, and that was used by pretty much any company. And the first site that I thought about was obviously GitHub. I haven't seen a company yet that doesn't use GitHub, if not for their internal code, at the very least, to pull some information and to pull maybe external libraries and things like that. Thank you, sir. Now was the time to decide which language I would use to build the C2 framework. And I want to be clear, I am not a programmer. Je ne suis pas un programmeur. Yo no soy programador. Yeah, I'm flexing some language skill for the two people in the audience that didn't figure out that I was not a native English speaker yet. So the two languages that I had in mind were Rust and Go, because I wanted a language that could cross-compile into the major platform, Linux, Mac, and Windows. And again, I don't know anything about programming, so I was watching a webcast from Black Hills InfoSec, and if you don't know about them or know about their webcast, you should really give it a look. They do like weekly content, and sometimes they post like 2 webinars a week. Everything is free, everything is recorded. Anyway, look at them if you haven't. So the guy was presenting his own C2 that he developed in Rust. And he was telling how great Rust was as creating C2 framework because it has, it's easy to change variables from one type to another. It has very low-level integration because it's based on C. So it seemed great. So I was like, yay, I found my language. I'm gonna learn Rust. Woohoo! But yeah, you need to learn Rust. So the first thing is, just when I was started, Rastamouse from 0 Point Security released a free class on getting started with Rust. So I took that class, It's a pretty short class, and I have to admit that after taking that class, I was still not able to program in Rust. I had a basic understanding of how to start a project, but not really how to code anything of significance. Luckily for me, even though I was not part of my company anymore, I still had access to LinkedIn Learning. So I went there and I took a class several days long with, I think, at least 10 different exercises to build from scratch. And interestingly enough, one of these exercises is actually part of the C2 framework, because there's a module about generating random strings, random numbers, and that's pretty useful when you build a C2 framework. And after that class, I could actually now start coding. So I was thinking about the guiding principles and the architecture that I wanted for the C2. And as a guiding principle, the name is LOWC2 because of living off the web, but also because I wanted it to be low and slow. I wanted the binary to look very, like, not evil if anyone would look into them. So the only thing that I really wanted was the ability to read command and output the command and be able to read it and retrieve them from somewhere else. So here's an overview of the architecture that I had in mind. So first of all, when you run the nodes or the beacon, it will generate a UUID, so a unique ID. Because it's always the goal to be able to run it on different platforms, it will tell you on which platform it actually runs. It will generate a public key pair, public-private key pair, and the URI that it's going to look for their next, to pull the commands. So every time you pull commands, I wanted to have a random name that change for every single node. So that's step one. And then it writes that to a GitHub repository that is for the output. Then the server will pull that information, store it to disk, and then you would send some commands. So here's an example, who am I, and ping, to see who's you're running from, and do you have internet access? Some very basic information you typically want to know when you are on a new host. So that goes to another repository that I call the command repository. And of course, the node will pick up those commands, run them, and send the output back to the output repository. And again, we'll encrypt it. We'll go over that a little bit later. And provide the next URI that it's going to look for in the command repository. Again, the server will pick up that information, write it to disk. So this way, you don't need to run the same command twice on any host. You always have the information at hand. So cool architecture. Now it's time to start coding in Rust. And it very quickly became clear that I made a very poor choice trying to do everything in Rust. So I'll walk you through some of these steps, right? So the first thing I tried to do was manipulating Git repository in Rust. And you would think that there's a comprehensive library that would allow you to manipulate GitHub repository just as you can in the command line. So creating a branch, committing some files, adding them to a repository, maybe create a branch, change a branch, delete a branch. But no, everything needs to be coded from scratch. You have like the very basic elements, but nothing that is easy to use. So there was a lot of blood, sweat, and many, many tears, and a lot of Stack Overflow, obviously, in order to be able to just work with the GitHub repository. There was one function that I could not find any documentation on, and that is deleting a branch from a repository. And that's maybe like a year and a half ago that I was doing this. And that's just when ChatGPT, and I promise it's the only time I'm going to mention that in the whole talk, but I had to ask ChatGPT, how do you delete a branch in Rust? And it gave me a function to delete a branch in Rust, and I could not find anything in the library or the crate documentation on Stack Overflow or anywhere. So I guess people don't like to delete branch, I don't know. But yeah, very strange. So that's the other part of the code that is directly from ChatGPT, and the other one was from the class. Now that I was able to manipulate a repository, it was time to actually run command on the nodes. And this part was actually very, very easy to do. Unlike the other crate, the crate to run command is super easy. You set the command that you want to run, and then in an array, you just add all of the arguments that you want it to run. And it runs on every platform the same way. Very easy, super cool. Now it was time to encrypt the exchange because I didn't want anything in clear text. So I had to choose the cipher, and it was clear in my mind that I wanted a public key infrastructure or public key asymmetric encryption. I wanted to be able to store the public keys in a file in order to survive server crash. And I also needed to store the resulting encrypting data into a file. So I mentioned very quickly, but surviving the crash. So if your server reboots or crash, you need to still be able to talk with all of your nodes, right? So you need the node ID somewhere with the key, the public key that it uses, and of course, as I mentioned, the next command file name that is going to look for. Otherwise, you will never be able to talk with your nodes again. So I had to load an array. So the public key is in the form of an array. And oh yeah, by the way, my employer did not approve any of those slides or the content. Now you know why. So yeah, loading arrays in Rust. So one thing that is important to know about Rust is that you cannot compile your program if you don't specify the length of an array. It just won't compile. But I never knew exactly how long the public key would be, so I could not initiate the array with a random value. I worked on this seriously for 3 or 4 full days. I tried many, many ideas. I tried to initiate a very long array, put the thing in it, but it wouldn't load, or the key would be unusable. I tried to use tuples and then convert it into an array, because if you remember the first slide as to why I chose Rust, it's supposed to be easy to convert from one type of variable to the other. It's not. So after there's 4 days of working on this, many, many hours a day, I decided to take a break, take care of the family, it was probably the weekend. And then at the end of this weekend, it kind of dawned on me. I think I was eating cereals or something like that, and I was, oh my God, I think there's actually a function to load the key back into the software. So I sit down on the computer, look at it, and all and behold, there was actually a function to just load it. It was just one line of code, and you can re-import your file, your key within the software. And I looked into the code, and it was doing the exact same thing that I was trying to do for the last 4 days, except they were allowed to do it, and not me for some reason that I don't know. So if anyone is very good with Rust, maybe you can explain to me why I was not able to do it, and they were. Now I want to go about some of the OPSEC considerations that went in building the C2 framework. So first of all, as I mentioned, I'm using GitHub, I'm using private repository, and I'm using 2 different repositories. In order to read and write from a GitHub repository or private, you need GitHub access token. So you need to be very careful about what permission you give to those tokens. And right now, in the current implementation, the tokens are available in clear text in the binary file. So if you use strings, you would get access to the tokens, and so you can kind of control the repository. This is not the best. There is a library or a crate that allows you to encrypt secrets within your Rust binary, but in order to work, you need to set up system variable. And at the time, I didn't know, or I didn't really figure how I could set a system variable before running my Rust command. Now that I'm looking at it again from a few months after, or actually even a year after, it's pretty easy. You create a batch file. In the batch file, you set the environment variable, you run your binary, and then you delete the batch file. The problem with that is that any files that run something and deletes itself is super suspicious. Believe me, I work for an EDR company. So yeah, there's no easy answer here as to how, in my opinion, yet, how to fix that problem. I also wanted to have some anti-incident response strategy. So I created, as I think I mentioned it, but random file names for the command line. So every time there's a new command, it will be posted under a new name, and each node will know which file belongs to it. The other problem that I had to face, or that I was trying to do, is you probably know that if you commit a file to GitHub, even if you delete the file, there will always be a copy somewhere on Git. So the only thing I could think of, and again, maybe someone who knows Git better than me will prove me wrong here, but the idea that I had is I will create a branch. That's where the node will put the output, and when the server pulls that branch and decrypt the packet, it will delete the branch without ever committing it. So I thought I was pretty clever, but maybe not. Now that pretty much everything that I wanted to do worked, it was time for cross-compilation, because for now, since everything was done on Mac, the node and the server. Again, one of the reasons why I chose Rust is because it's cross-compiling, and it was kind of easy to create that. There was just a few gotcha, and I created a gist on my GitHub repository to for some notes. But the main one was that to compile the Linux version, because there's encryption involved, you actually need to have the OpenSSL Linux library in your folder, in your compile folder. For Windows, it was another problem, and I will talk about it in a minute. Next was preventing the node to crash. If you worked with Rust, you know that it's a big problem. Because it does sound easy, but you have to understand that Rust will always prefer to crash rather than do a buffer overflow. So for example, if you read a file that doesn't exist, it crashes. If you try to write to a directory that doesn't exist or that you don't have the permission, it will crash. If you use / instead of / in a Windows path, it will crash. If you make a typo in the command you want to run, it will crash. If you, it will crash. If you, it will crash. If you, it will crash, right? Crash all the time. And when you work very hard to get initial access, you don't want to lose your nodes. So, yeah, just a lot of things went in to make sure that the nodes will never crash. Now I want to give a few tips for the Defender. I've created a software, even though I'm not releasing the public version of the C2, because again, I don't think that's what the world needs, and I've been involved in many incident response that included either free or leaked C2 or even C4 framework. I'm releasing this tool today that I called Seemingly Bacon, which kind of in French goes with the fake bacon bits, so I thought it was pretty funny. And by default, the tool will go to github.com/Microsoft/VS Code and will pull random files from that repository. And to mimic the way the node works, it will pull the same file up to 10 times. It's a random number. Then it will change to another file. The beaconing, by default, is every 60 minutes with 100% jitter, which means that effectively, it will pull the site between 0 and 120 minutes every time. There is also the LOWC project, standing for Living Off Trusted Sites. So I call it LOW, they call it LOWC, but it's the exact same thing. And if you look at this website, you'll see that GitHub is tagged for fishing and downloading. There's no mention of C2, there's no mention of exfiltration. So I've asked them to add those, but I looked this morning and it was not added. John Hammond, this guy, if you're visual, everyone's favorite hacker, also released a video about 5 or 6 months ago now called Hacker Use GitHub for Malware, where he explains how threat actor can easily use an issue to drop a file in a GitHub repository, and then it looks like they are hosting the file, even though they don't even know it's there. And after that, at this timestamp that I've noted here, he also explains how he used GitHub as a C2 channel. So he uses slightly differently than I do. He used the release feature, and every time you release something, his beacon reads that new release. So it just looks like it's always pulling release. That's the only suspicious thing. Now I know that typing these types of URL is difficult, so I've made a QR code. If you trust me, you can scan it. The original version had a cute YouTube logo that made it look a lot more genuine, but it expired and they asked money for a QR code, which I thought was a bit stupid to do. I see someone there. Maybe you can ask them if they got hacked or if they actually went into YouTube. So if you like the content, you can give me a follow on Xitter or Blue Sky, or here's my LinkedIn profile. I see that Mark is on stage, which means that I'm probably off for some questions.